Hey everybody, and welcome back to another video on my channel. So I figured I'd do another video in the WTF Are the Basics, where in this video I want to go over what a vector is for y'all, because I know for me when I first started out, a vector was something that went completely over my head, where it wasn't until just kind of recently when I did do the Gas from Scratch series that I started understanding like how vectors work to a certain extent, you know, the kind of cool things you can do with them and stuff like that, right? So that's what we're going to take a look at today in this video. So what exactly is a vector? So a vector is essentially a collection of three values that represent a point or direction in a 3D space. These values are typically referred to as the X, Y, Z components corresponding to the three axes of a 3D world, essentially. So you can see right here, and let me kind of give you an example of how, like a visual representation of what these look like. So if we go into the viewport, right, and I click on my character, you'll notice that the red right here, if we look at the transform of the character on the right side, that our red is going to be the X values of our different transforms, like our location, rotation, and scale, right? So the red indicates that is our X axis, which means it'll be going left or right of the character. So that is one part of the vector for our character or an object in a 3D space. The second one would be the Y, which is indicated by the green, which would be our forward, backward motion or location, stuff like that. And then our Z value of the 3D axis or world would be the blue as indicated, and that is responsible for our up and down vertical motions for our characters. So in a sense, a vector, like I said, is typically referred to as the X, Y, and the Z components of a 3D world or object space. So when we look at the reference, you could see that we also have an X, Y, Z on here because we can do different stuff or retrieve different information from it, right? So, you know, vectors are pretty much used to kind of represent things like the positions, like where we're located at in the world or where an object is located in the world, our direction, in which case like where the object is facing or where we're facing or moving, or to do like stuff like generate forces, right? So like there's nodes like add force or add impulse, which will typically apply like a physical force or impulse, like movement type of the object to force it within a certain direction. So if you ever see, you know, tutorials online in regards to how to make like your first Pong game, right? Because everybody has to go through that. You may see different videos where some people will use add impulse or add force to start launching the ball in a direction, which would be on a vector scale. So in regards to saying that, I do have a few examples to go over to try to alleviate any confusion that people may have in regards to vectors. So let's go ahead and look at our first example that I have, which is getting the velocity of our character. So in this case, in a mathematical sense, and I've mentioned it in some of my other videos, but in this, I wanted to kind of go over it heavily. So our velocity is retrieved from our character movement, right? So what our velocity is doing, and it's a read-only value, is velocity in a mathematical sense is your speed within a direction that you're going. So if I were to say that I am going 50 miles per hour east, then my velocity is 50 miles per hour eastward, or in this case, 50 miles per hour on the left side of the x-axis, stuff like that, right? Or if I were to go 80 miles per hour northward, you know, then I am going 80 miles per hour north. That is our velocity, because again, we provided a speed and a direction for our character. So if I'm going north, that would indicate maybe on our y-axis, right? So we're going 50 miles per hour, you know, on the y. And then for our z, which is up and down, like let's say I jumped in the air at a rate of, let's say 20 miles per hour, like I'm just superhuman and I was capable of doing that, right? So I just like jumped at 70 miles or 20 miles per hour up and then fell at a rate of, let's say, 50 miles per hour. So on the scale on the z-axis, I went upward 20 miles per hour and then came downward at 50 miles per hour. So that's how you would do it. So to see this in action of how we would retrieve it, I have an event tick on which we'll see these values change as we move along. So I'm going to connect my sequence node into the reroute pin that I have here, compile and save, and I'm going to hit play. So as you can see, because we're not moving, we're not going anywhere first, that our X, Y, and Z vector values are currently set to 0. But, however, as soon as I start moving, you'll notice that on the X, we're going 500, Y at 13 or whatever. But as you can see, because we now come to a stop, our Y, you can see that we're ever transitioning to the right at 3 centimeters per second, but our X is stopped because we are stopped. But then if I turn around, you can see we have a negative 500 on the X because, you know, we are moving backward or moving, you know, in a negative direction, you know, as such. So that's how you have to look at it. And then if I go, let's say to the right, it's a Y of 500. If I go to the left, that's negative 500. And the reason for negatives is because when we look at the viewport, when we look at our character, the left is going to be our negative value. So if you ever look, you know, if you all recall in math class where on a grid you had like your X and Y axis, and anything to the left of 0 or anything to the left of 0 on the graph is a negative number and anything on the right is a positive number. That's essentially what's going on here in a 3D space. Anytime we go to the left or down, we're getting a, or in this case backward, we're getting a negative number. When we go right and then forward or forward, then we get a positive number. Same thing with the Z. Say, just kind of change how you look at the Z. If we go up, that's a positive. If we're going down, you know, just like in a graph on the Y, right, then we're getting a negative. So that's what's going on there. So then if I go back into play, as you can see, when I'm jumping, the Z generates a positive number when we're jumping in the air, and then a negative as we're falling. So in some of the videos that I've done with chooser tables and how you can set up functions to check if you're jumping or falling, that's why in a sense you'll see me use velocity, where I would split the structure pin so I only get the Z, but then I'm checking that if we're less than 100 that we are falling, or if we're more than 100 then we are jumping in the air, right? But then you might have something else on the Z to indicate, you know, a loop for the animation where it's like, hey, we've reached the peak of our jump, right? So that's kind of how it looks there. So now in this case, for my second example, is I have a pure function that is provided by Unreal Engine that allows us to get our actor's location. So in this case, our target, because we have it set in here, because target is actor, which is just a generalized function or generalized target. So whatever we apply this to, whether it's our character or an AI character that we've made, this will be on, you know, indicative of that target's value or that location that they are at. So in this case, we're getting our third person self for this actor location. So if off my sequence node, if I connect the 0 pin here and I compile and save, when we hit play, you can see that our location within the 3D space, we are no longer getting our movement where we are going like a certain miles per hour in a direction. Now we're getting our location, you know, or our position within the 3D world space. So currently my character is located at the X of 900, at the Y of 1110, and at a Z of positive 92. So say, because I know where the world origin is, I'm going to start there, or I'm going to make my way to there and show you how we then transform our actor location values as such, and show you some, like, talk about some of the cool things you can do, right? So if we go to the world origin space, which I can only get as close as I can because that's, you know, it's over here, you can see how we drastically shifted our X and our Y value to 135, or approximately 135, because the closer we get to the world origin, the more zero-ish it'll become, or the closer to zero it'll become. But you can see how it's getting our actor location where we're moving at. So say you're trying to get the location of where a certain actor will be, well, that's how you'll do it. Or say you maybe want to transform where they go to, right? So say, for example, you want a platform to start at an XYZ of whatever, but then you create a timeline into which you then move the XYZ to like a different location. Like say, for example, and let me hop up here, right? That you had a floating platform that started from the corner of that play area and came through here to where you can then like run onto it or jump onto it, right? Well, like I said, you would probably put an XYZ value of a start point of over there, and then a timeline in which over time or game seconds, it'll then transition to here and then stop right in front of us, which would be, you know, like an X of 100, like 1,400, but maybe a Y of 2,500, so it ends up right in front of us. So pretty much kind of like, yeah, around 2464 for the Y, stuff like that. But then its Z would be maintained at 292, right? So that would be an example of how you can utilize an actor location where it's like, hey, get its starting point in the world and then move it here, and then when it's done, move it back with a timeline. So that is another example of how you can use vector values with like a built-in function as such. So now my third example would be to get an actor forward vector. So as you can see reading this is another vector type. However, we're getting the forward X vector length from this actor in the world space. So specifically what we're doing here is we are getting directly in front of us. So there's some things that go on behind the scenes that kind of transition that make our X what's in front of us. And our Y is our like left and right in this instance. But I'm not sure where that's happening, but when we hit play, you can see that our X is at a 1, because in this instance what we're doing is we're capturing data that is in front of us, right? So directly ahead of us. So if we were to do, like, for example, a line trace of sorts where we want to jut out in front of us like 200, units, then it would probably start like somewhere in this area and then jut out this far. So when we look at that, and apologies for the dry mouth, guys. So when we look at it, our X, changes, or our Y changes, depending on where we're looking, because depending on where we look is technically our new forward vector. So if we are going on the Y, then you could see that it generates a 1 depending on where I look. So like to the left would be, or the right in this case, but in the world space left, we get a -1, but in the right of the world space, we get a +1 for the Y. But then going on the negative of the world space for X, we get a -1, and then on the positive world space, we get a +1. So that's how you can get a forward vector to do stuff. So if you've ever played around with the game animation sample project, for example, it does some stuff with the vector value or the trace distance in front, or maybe, for example, in a simpler term, say you're doing a line trace and you want the line trace to end in front of your character. Well, you would grab the vector value or the get vector actor forward vector, so that way at some point during your offsetting of the line trace that you would end up with a line directly in front of your character. So that's how that can work. Our next example would be to look at, converting velocity into a float value. For example, like if you've ever played in the animation blueprint of the third person template, that you will notice that, velocity will be a set node here, but then you'll retrieve the vector length XY, and then there will be a thing called ground speed here. So what this does essentially is it kind of converges the X and Y components of the vector 3D space to return your speed in like whatever direction on the ground you're going. That's why they convert it into a set variable called ground speed in the animation blueprint. So to demonstrate what it's doing, so let me hook up the sequence node to it, and if we hit compile and save and try to print it, you'll see that instead of 3 values, we get just 1. And as you can see, that wherever we're moving, that we are getting 500, and where they're getting that 500 is our max walk speed. So that is how they're returning the ground speed in the anim blueprint to do certain animations, you know, is because they are taking the velocity, which is a vector value, and converting it into a float, because like I said, it basically converges, or in simpler terms, like merges to a certain degree, the X and Y component to just return the velocity of like a single axis. And I throw that in quotes because you're not really getting a single axis. What it's trying to do is, you know, if I were to move, you know, left or right, it would have been a Y of, you know, 500 or negative 500, but then if I move backward and forward in the world space, it would have been 500 and negative 500 on the X. All they're doing is converting that into one value for you to get a ground speed. So the next example that I have would be and I have a left mouse button set for debugging. So you'll see something like this on occasion, where you may have a set actor transform, right? Or maybe a set actor location, but I'm gonna do a set actor transform just because it has 2 vector values that I would like to change to show you how this can work, because one, we have our location, and the other one is a scale vector value. So in this example, what I wanna do is look at the location vector of the transform. So as you can see, we have a 1000, 1000, 1000 on the XYZ. Because what we can do is when I connect the pressed button to the set actor transform, basically what I'm doing is like a pseudo teleportation, which is what I'm going to show you in just a moment. Because what you can do in the game world with vectors, because again, a vector is made of XYZ components in a 3D world space. So, you know, how we got the actor location in example 2, where you could see the changes in the actor location, or how I told you about how you can get a platform with a timeline where it moves forward and backward on a specific axis or whatever, or axes. The set actor transform, what you can do is do like a teleportation of sorts, or like, you know, how you can fast travel maybe in a video game, where once you get more complex at building a you know, fast travel points, you can then set actor transforms to teleport to that location. So for example, if I hit compile and save and I hit play, as you saw from the actor location of earlier, I should be on the X of 900 and the Y of 1100 and the Z of, you know, 92. But then as soon as I click the left mouse button, you can see how we teleported upward 1000, and then we moved over on the X to 1000, and then we moved to the Y location of 1000. So you can see how I'm basically teleporting, and as every time I click it, that our vector value, or our 3 points on the axis, we've set our character to just move to that location. So that's a good look at how, you know, the second example looks if we were to try to transform that location, or the current actor's location. So for our last example that I have set up, I have something else where basically we are going to look at transforming the scale of our character, because it doesn't necessarily have to be, you know, a position where we're located, or a direction that we're going in, like a forward vector, or applying force to objects. Scale is another vector where, you know, when you transform your character, as you can see like on the right, where our character has a size of 111, you know, what we can do for certain objects is like, say, you know, for example, Mario, right? When you overlap with a mushroom and that mushroom makes you bigger, technically you are transforming the scale of that character to be bigger, and then after a certain duration, you then transform it back down to being smaller. So that's kind of how, you know, a good example of Mario, right? Where I can do something like this, because I'll show you. So if we do compile and save, and the reason I have a get actor location here is because I don't want to change my actor's location to 000 or we fall off the world. I just want to keep them where it's at. So that's why I have a get actor location here. So if I hit play and now look at the scale, right? So as soon as I click my left mouse button, you can see that we have transformed to be a giant in our world. And because we are very giant, that we are moving slower, but technically we are moving 500 centimeters per second. It's just in this case, if we do become a giant, you would want to figure out how to alter the max speed, while in this state, right? So let's say, for example, like the example I talked about with the Super Mario mushroom, right? Say, I drag off of here and I want to do a, delay node, because after a certain amount of time, I want them to transform back. So basically, I'm going to copy these and paste them over here. And, after, let's say, 5 seconds, I want my character to go back down to being 1, 1, 1, right? Just like that. So, in saying that, if we compile and save now, and boom, I hit my left mouse button, we're giant, but then after 5 seconds, we should transform back, as you can see, to 1, 1, 1. Just like how Mario goes back to being normal size, like after like a temporary mushroom or something, or after he gets hit, right? So, or like his gigantification mushroom, where after a certain amount of time, he goes back. So, that's how you can do certain things with vector values, or those are some basic examples of how to utilize the different vector values, especially with these vector values being very common values that you will see, within the Unreal Engine environment. So there are definitely more complex examples of doing stuff like this, which I can definitely show if, y'all want to see that as well. But for this point, I'm trying to go over the basics. So, once again, just to kind of reiterate what we've done, right? So, a vector value is essentially just a collection of the XYZ components in a 3D world space, where it can either represent our position, our direction, our location, our scale, stuff like that, right? Where, as you've seen, where we've gotten the XYZ speeds of our character. We've gotten the actor's location, where their point is at in the world. We also looked at, talking about line tracing to a certain degree, where getting the actor's forward vector, that would be a direction, where you can then, kind of, do a promote to variable and call it forward direction, because it is our forward vector direction. And then how you can convert velocity into a single access point, because of how it can merge two separate velocities to get our ground speed. Where if you did a normal vector length, where if you got where it just says vector length, that then returns all the values. So your X would return 500, Y would return 500, your Z would return 500, or wherever it's X, it's trying to collect all the points. But this example is like what's set in the anim BP, where you would be getting ground speed because you want to save jump for something else. And then we also took a look at how you can change the actor's location, or like I said, where you can make like a timeline for a moving platform, where it'll, go forward and backward on a point, where you would set the new actor transform to the new location you want it to be at. And then when it's there, you can then reverse that direction so it goes back to the original point. So again, like moving platforms, and then the last example, as you've seen, of how we can then rescale our character to where, say you add a power up where it's like, okay, now we're huge, right? And we want to go, from the being a 1-1-1 scale to a giant scale, and then on that giant scale we increase our, let's say, walk speed, so we walk even faster while we're a giant. But then while we're a giant, we have 2 times or 3 times or 4 times the power, because we're so huge, right? Stuff like that. So like I said, guys, these are just the basics examples that I wanted to go over to hopefully alleviate any sort of confusion that you may have with a vector value. So if you did enjoy that, guys, I am glad. Hopefully my points were able to kind of educate y'all as far as velocity or just vectors in general. So if you did enjoy that, guys, please check out my other videos and my future videos to come. But other than that, y'all have a great rest of your day and take care.